morning, students. In the last lecture, we discussed about the thermodynamic process can be changed in different ways. Thermodynamic change is depend upon the initial state as well as it is also depend upon the intermediate state. Today, we are going to discuss a very important topic in the thermodynamic, which is nothing but the reversible and irreversible processes. Now we know that a thermodynamic system can be completely explained or described by the state variables. And what are the state variables? We know what are the state variables. The state variables are the pressure, volume, temperature. Here we restrict ourselves these three state variables to explain this reversible and irreversible processes. Now, when two or more than two state variable changes, when two or more than two state variable changes, then we say that it is a thermodynamic process and the system undergo a thermodynamic change. So, when we considering this state variable for a the system undergo a thermodynamic change which is called as a thermodynamic process. Two or more than two state variables must be changed from initial state to the final state. It is called as a thermodynamic change, or it is also called as a thermodynamic process. Now, we know that there are different ways to change the state of the thermodynamic system, to convert a system from state 1 to the state 2. In the earlier lecture, we discussed about the work done and heat added, which is takes a different values when it travels through the different paths from state 1 to the state 2. Here, to classify the thermodynamic process, we keep a state variable constant and vary the other two variables. It means out of these three variables, either we can keep pressure constant and we vary volume versus temperature, or we keep volume constant and we vary pressure and temperature, or we can also keep the temperature constant and vary pressure and volume. So, by this way, we can explain the thermodynamic process, and the thermodynamic process either it may be reversible or it may be an irreversible process. So, we are going to discuss in detail this reversible and irreversible process. Now, we know that when two bodies at the different temperature bring in contact with each other. For example, consider these two bodies. This body is at 70 degrees Celsius and this body is at 30 degrees Celsius. When two bodies having different temperatures bring in contact with each other, what happens? The hot body loses the heat and the cold body gains the heat. Okay, the heat is lost by the hot body and the heat gained by the cold body until a thermal equilibrium takes place. What is thermal equilibrium? Suppose that the thermal equilibrium is at 40 degrees Celsius. Then when the temperature of these two bodies become 40 degrees Celsius, we can say that these two bodies are in thermal equilibrium. It is also depend upon the temperature of the surrounding. So, when such type of condition or case arises when two bodies of different temperature bring in contact with each other, the hot body loses the heat and the cold body gains the heat. So we can say that this process continues till a thermal equilibrium is reached. Now consider after that the hot body retrace or hot body when become in the thermal equilibrium, in these two bodies are in thermal equilibrium, then what is the condition? Can we see the hot body attain its original temperature or the cold body attain its original temperature? It is not possible. Okay, we can say that when these two bodies either gain energy, gain heat or lose heat, they in the thermal equilibrium, and when the thermal equilibrium reach, they can't restore their original condition. Their original condition what? This hot body can't reach 70 degrees Celsius and this cold body can't reach 30 degrees Celsius. So such type of process is called as the irreversible process. Okay, such type of process is called as the irreversible process, in which the initial state of the system can't attain, can't restore. Such type of process is called as the irreversible processes. Now what are the examples of irreversible processes? The irreversible processes are nothing but when we rub our hand, when a balloon is punctured, such type of system is called as a irreversible system. They can't get reverse and they can't attain their original condition or initial state. So such type of processes which can't attain the initial state is called as the irreversible process. And what are the examples of irreversible processes? Puncturing of a inflated balloon, or it is also when we rubbing our palms, it is also a irreversible process. Now the another type of process is called as the reversible process. So what is the reversible process? When the ice melt, when the water boils, such type of processes are called as the reversible processes, because when they change their state from state 1 to state 2, they retrace, or the initial condition of the system can be restored. For example, when ice melt, when the ice melt, it converted into water, but when the water freezes, the temperature of the water decreases, then it is converted into the ice. So ice into water, or when the water boils, it go into the vapor state. So when the vapor state cold, it is also converted into the water. So these are the examples in which the initial condition, initial state of the system can be restored. Such type of process is called as the reversible process. Okay, now we are going to explain the reversible process and irreversible process by a diagram which is nothing but the PV diagram. We also stated earlier that while classifying the processes, while classifying the thermodynamic processes, here we are going to keep a state variable constant and the other two are varied. Here we are going to discuss the reversible and irreversible process by using a PV diagram, means the temperature of the system get constant. So we first of all say what is the reversible reaction. Okay, a simple diagram, PV diagram. This is pressure, this is volume, and such type of process. This is point A and this is point B. So what happened? What is such type of process? Such type of process, for example, consider here is Vi and this is Vf. Therefore, this is Pf and this is Pi. Here, this Pi and Vi, they are the initial state of the thermodynamic system, and after changing Pf and Vf be their final state. Okay, and this all happen at a constant temperature. To keep the constant temperature, the process must be slow, or it is also known as a quasi-static process. Now, what happened in this case? In this case, we are going to see a process which is traveling from, or which is going from A to B. Which type of process is this? This is nothing but the expansion. Why expansion? Because as we are going, or as we decreasing the pressure, the volume increases, and as the volume increases, it is nothing but the expansion. So when we considering a process thermodynamic change from A to B, it is nothing but a expansion from A to B. It is nothing but a isothermal expansion. Remember, isothermal means the process when the thermodynamic process change from A to B, its temperature remains constant, means it is a isothermal process. So we can write here also isothermal expansion when we are going from point A to point B. It is called as the isothermal expansion, and the path is shown like this. Now, this process can be reversed. This process can be reversed, and the reverse process is called compression. When we are going from B to A, that is, when we tracing a path from B to A, it is nothing but a isothermal compression. So, what are the characteristics of this reversible processes? The PV diagram of a reversible process is as shown in the diagram. The path followed by the thermodynamic system during the reversible process is equal in the reverse condition also. Means the path followed by A to B and B to A, they are same in the case of reversible process. Such type of process is a quasi-static process, means such type of process is taking place at a very slow rate at the constant temperature, because we know that to keep the temperature of the system constant, the process must be slow. If the process is rapid, there is sudden increase in the temperature of the system. So if the temperature remaining constant, the process must be slow. So here we discuss about the reversible process by using a PV diagram and keeping the temperature constant, in which the path of expansion and the path of compression, they are exactly opposite or reverse to each other. The path followed by during the compression and the path followed by the path followed by the expansion and path followed by the compression, they are exactly opposite direction in the same direction. Okay, in the opposite way but in the same path. Okay, now we are going to explain the irreversible process using the PV diagram. Look here, this is pressure, this is volume, Now, so such type of process is called as a irreversible process. Why? Because we already learned that in the reversible process the same path followed by the expansion as well as the compression, and it is a reversible process. Now, what about this? In this case, a thermodynamic system undergo a change, and when we are trying to retrace, the path can't retrace. Okay, it can be reversed by another way. It comes to the initial state by another way, but it doesn't follow the original path. Such type of process is called as the irreversible process. Okay, now in the case of reversible process, the energy of the system remains constant. The energy of the system remains constant because there is no loss of energy during the process. And as we know, during the expansion and during the compression, the energy loss is gain also in the reverse direction. So we can say that the total energy of the system remains constant in the case of reversible process, but in the case of irreversible process, the energy of the system does not remain constant, because during such type of thermodynamic process some energy, some heat go to the surrounding or go to the wastage. So we can say that the initial energy of the system is not equal to the final energy of the system. The energy is lost due to the friction, viscosity, etc. These are the reasons due to which the irreversible process can get reversed to the initial state by losing some heat. So here we discuss about the reversible process and irreversible process by using this PV diagram, in which we vary pressure and volume of the system but the temperature kept constant. Here we are going to stop now. In the next lecture we are going to discuss another very important topic, which is nothing but a isothermal process. Okay, this is about today. Thank you. Have a nice day.